We are recording. Good luck. Have fun. I'll be back in a while.
Thanks a bunch, Sarah. I appreciate it.
No problem.
All right. All right, folks. So we have a demo-rich meeting today. I will put into the chat the link to the agenda. And I think first up is the Deus demo. So Jason, I think you were going to do the intro. Do you want to take it away?
Yeah, for sure.
All right.
Thanks for giving us some time. I'm going to go ahead and go through a quick deck talking about how we're thinking about Service Broker. We've got a new project we're calling Steward, so I'll give an intro to that. And then Aaron from the Deus team is going to run through an implementation of the Cloud Foundry mode just for some context. So let me share the screen here. And all right, can everyone see my screen or anyone see it?
I can see it.
Okay, awesome. Let me get the chat up here as well. All right, so the project that we've been working on around the service broker space is called Steward, and Steward looks after all the passengers on the good ship Kubernetes. At a high level, when we're talking about applications, no application is an island. It needs services. It needs to be able to request and connect to those services. This is a list of those questions that sort of come up, which should be no surprise to folks in this SIG. How do I find the applications the things that my app needs? How do I request access to those? How do I connect to those? How do I tell my app to use those things? And then from an operator standpoint is how do I expose services to folks on the cluster? How do I expose new things? And then how do I take new fancy applications and connect them to legacy infrastructure? For us, the answer is Steward. Steward is a tool, utility that facilitates all of the things, right? It started with a couple of design goals. One, first and foremost, is make it very easy to expose and consume services. Decouple provider from consumer in the standard service broker model. Build primarily on Kubernetes resources, so use Kubernetes for persistence, as well as third-party resources, config maps, and secrets wherever possible. And then use standard interfaces where they're available for things like provisioning and deprovisioning, binding, unbinding, using config maps as configuration. So to that end, we've got the high-level pieces that are functioning here. We've got a service catalog, which is persisted as a third-party resource in the Kubernetes API. We've got applications and application developers, who kind of lump them into the same category. Some notion of a broker, and then some service provider. So this service provider would be something like SendGrid or RDS or some configuration of software that gets stood up. The broker, the thing that mediates access to that, and then the application, which is going to be consuming those resources. Overall, we've got this sort of cast of characters. I think the big one here is going to be what requestable service is. That's some service that exists in the context of a service catalog. The catalog is the list of all of those services. And then service claim, which is how an application developer packages up their intent to get access to a service. So we've got the notion of a service claim. Steward sits between the application and the app devs. It reads to and publishes, reads from the service catalog and publishes to the service catalog, and supports 3 modes. So when we're talking about modes, there's a Cloud Foundry Service Broker mode where Steward will interface with a Cloud Foundry standard service broker. A Helm Tiller mode where it will use Helm's Tiller, or the server-side component, as the service backend, and then a command mode, which is instantiating one-off pods that follow the sort of life cycle for provision, deprovision, bind, unbind. So insert in the Cloud Foundry Service Broker mode, which Aaron will show a little bit later, whatever the Cloud Foundry broker does, we just sort of pass that through. Along with the Cloud Foundry broker API. So steward's responsibilities at a high level, it will, when a steward starts, it will publish its own services to the service catalog in the third-party, as a third-party resource. And then it will start watching namespaces for service plan claims and manage interactions with the service backends. So as a service plan claim arrives in the cluster, it will notice that, see that it matches its set of services that it's watching over, providing, and then it will call out to Cloud Foundry Service Broker, call it to Helm, or instantiate some pods. So generally the workflow at a high level, the application developer will create a claim in their application namespace, and however they deliver that through hitting the API server or packaging that claim as part of their application chart or using kubectl to create it. That claim gets passed in. The claim will reference the catalog offering by service ID and plan ID, which is borrowed from the Cloud Foundry sort of broker API. It will also provide a target name for steward to write the service secrets. So it'll say, in my namespace, at this secret name, please inject the credentials from the backend interactions. Once steward sees that claim, it will manage an interface with the backend brokers. So in a cluster, we expect to have many stewards, all responsible for their own subset of services and plans. You could have a mixed deployment as well, where some stewards are using Cloud Foundry Broker APIs, some stewards are using Helm backends, and some stewards are just instantiating pods to follow along with that lifecycle. Once the result is complete from that broker or that server, that backend interaction, steward will take the credentials, which again informed by the Cloud Foundry Broker API, that the structure of that response, write it out as a secret in the namespace of the application, so that the application can mount that those resources however it would like to. So the three modes, I've got some diagrams here. This is just to help expand on what those modes actually mean. So again, here, steward, you can see the get v2 catalog. When steward starts, it'll hit the Cloud Foundry Service Broker, enumerate all of the services and plans that broker provides, and then publish those into the service catalog. So steward acts as that adapter between the Kubernetes universe and the Cloud Foundry Service Broker universe. And then as claims arrive, again, packaged by users or operators within the context of the Kubernetes cluster, it'll call out and do provision, bind, unbind, and deprovision as API invocations against the Cloud Foundry Service Broker. Same thing here in command mode. These are one-shot pods. Steward's responsible for setting up the pod environment, and then it will call into whatever image it is configured to launch. It'll call /bin/broker catalog, and then the responsibility of the contract right now to emit the JSON for a well-formed Cloud Foundry catalog. Same thing with provision, bind, unbind, and deprovision. We have a very lightweight API for these pods that has the information that it would need to be able to service those requests. And then the last mode is simply tiller as the backend. So we've got steward can start in a couple of different ways to interface with tiller, where it'll install the Helm chart when it launches, or it will expect the chart has already been installed and then just do bind. So those are the three modes at a high level. Before we jump into the demo, does anyone have any questions at this point?
So do you only create secrets from what is handed back from the Service Broker API, or do you create secrets and config maps? I heard both config maps and secrets mentioned, and then I heard only that you inject a secret to manage.
Right. So the reason I mentioned config maps is the service plan claim is currently put in as a config map.
Okay.
And then write out secrets. Something we did that is we ran all of the party for expediency's sake. We decided as the Kubernetes kind for service plan claims. Does that make sense a little bit more?
It actually came through a little attenuated for me. Did anybody else have issues hearing that?
Yeah, I couldn't really understand it.
Okay, you might want to repeat for the record.
right, so I got the unstable internet warning. So we use both secrets and configs. We currently use them for the service plan. Had problems with that have now been for expedience sake that our claims.
It's worse now than the first time. So it sounded like config map was used as an input and secret is the output.
Yeah, what I got from it is that the plan offerings are stored in a config map, and secrets are the actual interface to pods in a user's namespace. Accurate?
That's what it sounded like to me as well.
Yeah, this is Kent from Deus. I'll try to field the question. So actually, because until recently there have been issues having multiple types of third-party resources, what we are doing for the moment is that plan claims or service plan claims rather are submitted as a sort of config map. Yes, the output is a secret. The only thing that is actually a third-party resource for the moment is the entries in the service catalog. So entries in the service catalog are 3 PRs. Claims are config maps. The output is a secret.
Okay, I have some other questions, but I will hold them until after the demo, personally.
Cool. Aaron, you want to take it away then?
Yeah, so Jason, you're all done with the slides? I will take that as a yes.
Yes, go for it.
All right, let me go ahead and share my screen. All right. So we put together a couple of Helm charts to show off, as Jason said, the Cloud Foundry backend broker implementation. So everyone can go see this. It's github/deis/steward-demo-s3. And again, the intent here is we're just going to do 3 Helm installs, and in between I'll show kind of how everything works. So the first thing here we're going to do is we're going to install a steward and the backing Cloud Foundry broker. Actually, let me go back here and explain what the broker is. So the broker is an S3 broker, which is just going to create, it's going to create an S3 bucket on provision, and then it's going to create a new IAM credentials on bind, and it's going to return those IAM credentials as well as the bucket name in that secret that we were just referencing. So I'm going to go ahead and go into the S3 service provider chart. I've already put my AWS access key and access secret into my environment. Let me make this a little bit smaller here. So can everybody see all of this terminal output okay? Can anyone not see this?
I can see it.
All right, great. So I'm going to head over to charts, S3 service provider. I'm going to do that Helm install. Let me just copy this. So we got our new, show off the pods. So we've got our new broker up, and Steward is in the process of starting up. So while Steward is starting up, I'll show off that third-party resource that represents the catalog. So you can see here, this is the plan that we just created. The name is basically parsed out as the name of the broker here, and then this is the service name, and this is the plan name. And as we go through, as you go through the demo, you can see the output YAML of this and see quite a few more details about the plan. I'm going to omit that for now, but you can kind of catch it a little bit here. There's a plan ID and there's a plan name and so on and so forth. So let's make sure that pod is up now. So now that it's running, we're going to go in and create that claim. And again, the claim, if I can just show it for 1 second, the claim is that config map that I think both Jason and Kent mentioned. We are planning, once you can get multiple third-party resources kind of reliably posted up to the cluster, we are planning to make this into a true third-party resource and Steward has the flexibility implementation-wise to kind of make that transition. But for now, it's a config map, and this is kind of what it looks like. So this is the reference to the plan and the service. Right now, this claim ID is unused, but it's expected we'll use it in the future. Create is just a shortcut for provision and then bind. And we've been using it as that shortcut primarily. It will evolve in the future, we expect. But right now, yeah, it's just kind of the shortcut. And then again, this is that target name that Jason had mentioned. So this is the secret, the name of the secret in the Steward namespace in our case that we'll expect to see and that the app can then later mount. So I'm going to go a bit to the claim. We're going to do that install. Oops. We're going to go back out to the claim. We will do our Helm install. We're going to wait for that claim to come alive. We'll check out the claim first. That will be this one. And so nothing too surprising here. This is pretty much exactly what we put in, except for the status. So this status is a read-only field for the application and app dev, and it's write and read for Steward. So once Steward goes through kind of the state machine of the provision and then bind state, we'll see this status of bound get output. And that's how we as the application operator or developer knows that now the service has been provisioned and bound and we're ready to use it. So now that we're ready to use it, we'll do the last step here, which is going to be instantiate our program that we actually expect to be able to read that secret. So again, the Helm chart, fairly simple. We've got an image here that's kind of been pre-created. All it is going to be launched as a job. That image is simply going to upload an image of Crocodile Dundee in this specific case. And that's thanks to one of our engineers who is from Australia originally. It's going to upload that image of Crocodile Dundee to our newly created bucket with our IAM credentials. So let's go back and do that install. Go ahead and wait for that to be done. I'm going to watch the job. Looks like it's done. Looks like the pod should be disappeared now. And the final piece of the puzzle here is I'm just going to go to the S3 console. Hopefully I haven't been cursed by the demo gods. It looks like I haven't. So there's the image. Go ahead and download it, make sure it's the right thing, and there we have it. So that's kind of the overview of pretty simply how we can build an app that's kind of fronted, has a Cloud Foundry broker in the background that is fronted by Steward and has that sort of standard Kubernetes interface in front of Steward that we can take advantage of as the app developer. So I'm going to unshare my screen right now, and then we can talk about some questions. I see there's a bunch in the chat already. Cool. Well, thank you for the compliments, but I would like to open it for questions if anybody has any.
Yeah. So is it possible to use this with to create a secret in a namespace that isn't the one managed by Steward? Like, can you inject a service account token and say, I want you to create it in a target namespace?
No, we actually don't have that right now. Just for a little bit of history, Steward, sort of as the very first day, we did have Steward be able to write to any namespace. So it kind of had God mode. And then we talked about the service account implementation, which you just mentioned, but we haven't quite gotten there yet. So right now, it just writes the secret to the same namespace as the claim.
I gotcha. Cool. Let's see. So I was going to ask this question. I think I've answered it, but I'll ask it for the group. So there's no API that you're presenting, right? You're relying on third-party resource and then config map. Accurate?
That's accurate, yeah.
Okay. All right, any other questions?
And you can thank, I think he's on here, Lachlan Yeah, Lachlan Evanson. He's the Australian guy. You can thank him for the Crocodile Dundee.
I thought it might be Lachlan.
Oops. So the tiller is a direct backend. It's not fronted by a service broker. Does it adhere to more or less the same lifecycle interactions, though, as the service broker API, or is it significantly different?
It can be the same, but there are actually two modes that Steward can be configured for when running in tiller mode. So the one that is very similar to the broker is provision will install a new Helm chart, and then bind will inspect the output of the Helm chart to grab credentials to write back to the secret. The other way is fairly different in that when Steward starts up, it will expect that the chart is already installed, and provision just then is a no-op, and bind will then go and sort of collate the output of that chart into the secret.
And that's a Steward instantiation time level configuration, or it's a per service that you want to bind to?
It's a instantiation time.
Okay, and is that just for expedience in the demo, or do you expect it to really be used in dramatically different ways by different people?
At this point, we kind of don't know, so we wanted to leave both of these options open. But we kind of don't quite know exactly how people are going to expect this Helm interaction to work.
Okay.
Yeah, so we're just leaving it open.
Have you guys considered at all having some kind of convention or other way for service brokers to report back that like part of their payload is configuration, it's not secret, so you could differentiate like creating a secret or populating a secret in a namespace versus a config map in a namespace? That's one thing I struggle with a lot about the current broker API.
Yeah, that's an excellent point. Again, a tiny little bit of history. Steward originally tried to guess, which obviously not the best solution. And eventually, after kind of a few iterations, we decided to put everything in a secret. And the reason for that was we didn't want to at least extend the broker response API. And we also didn't really want to guess. So we settled for now on treating everything that comes back from the broker as sensitive data, and therefore we put it in the secret. But we are open to kind of extensions or new ways of determining what could go in a config map versus what must go into the secret.
Yeah, I think that what you guys did for now is reasonable. I'd really like to see like the working group, the CNCF working group, make an addition to the broker API to like differentiate the payload for secret versus config, because I think that would be like a really common case.
Yeah, I think that's a great option for that's conversation around creating a schema for that, because that would help, just a Boolean secret, non-secret, which would make that less opaque.
Yeah, agree. Okay, so it's about half after. I know there's another demo. Thanks a lot, guys, for your demo. I think Brendan from Google, you're on the hook for the service broker demo. Are you ready?
Yeah, sure.
All right. Well, you have the floor, sir.
Okay. So we don't have a slide deck, but I'll just walk you through before I do the actual demo what we've been working on. So we've been building a prototype starting more from the vanilla Cloud Foundry model of the principled service broker API as the service instance and service management API, and then the cloud controller service or system that lives on top of that manages different brokers that live in different places and manages the relationships of instances and bindings. So part of that has been teasing out from the existing Cloud Foundry cloud controller what can be generalized and made into what we've been calling the service controller, that management system, and then how we can use the Service Broker API to begin to deploy and manage white box services in a Kubernetes cluster, and within multiple Kubernetes clusters, really. So we have those two different systems we've been building as prototypes. So what this demo is going to go through is it's going to run a service controller, and it's going to run a service broker that manages services within a cluster and manages the catalog of what we call service types available within that cluster. And then we will deploy a guestbook app, which is a Node.js service that acts as a front end that is exposed to the world and you interact with over HTTP, and a MySQL service that is the persistence layer. And it will bind those two together so that they can work. And let me just figure out how to share my screen in this system. This is my first time, sorry. Okay, let's see here. Okay, can everybody see this this terminal window?
I can see it.
Okay, please speak up if you have any issues. I'm gonna biggie size it. Okay, so we have these two systems running. We have the service controller running, and we have a service broker running within the cluster that is managing the catalog and the instantiation and binding within the cluster. If you think back to the previous demo, there was the steward that does the procurement, the provisioning and the binding and unbinding and deprovisioning. That's the same relationship of the service controller to the service broker that lives in the cluster. So right now we have a basic CRUD CLI that we've written to talk to the service controller, but we're also working on integrating it into the third-party resources of Kubernetes, similar to what you were speaking about in the previous demo. But for now, so I'm going to run a magical script that sets all of this stuff up to get the demo started, and then I'll walk you through the different resources. Okay, so if we talk to our service controller, we can ask it what it has for services to deploy, and it currently has nothing because it's not hooked up to any service brokers. So the very first thing we need to do is add the service broker for our cluster. And you can see I'm actually running everything localhost right now on my laptop for the sake of the demo, but this broker would actually be running in the cluster. We're going to add this here, and we could add brokers for multiple clusters to manage across clusters. We could add brokers that manage black box services as well, if we wanted to. And once the broker has been added, similar to how Cloud Foundry works in general, we now have available to us the catalog from that broker. And you can see here there's a bunch of different services with plans that we can deploy. What we're most interested in is this guestbook Node.js and this guestbook MySQL, each of which have a single plan. And I'm hoping most people are familiar with the Cloud Foundry model, but if you're not, Cloud Foundry allows you to see service definitions, each of which has a name and several plans that it can deploy. A plan being a way to parameterize different styles of the service you want to deploy. In our case, we just have a single simple plan. So the first step is going to be that we want to create a service instance of the guestbook MySQL. And we're going to give it a name, and we're going to say we want the guestbook MySQL service, and we want the plan MySQL. So our broker is implemented in terms of Helm right now. So we have a service catalog that is dynamic. You can actually manage the service types available from your cluster. Add ones, remove ones, update them, and each service type, each plan in a service type is backed by a Helm chart that can do whatever it wants. In this case, it's just going to spin up a pod with MySQL running and a service to expose that. And if we want to, we can see that there should now be a MySQL service running in the cluster. So next we want to, well, let's take a look. We can see that there's now this service instance running as well in the service controller. So the next thing we want to do is create a new service instance. And we're going to call this our app. And it's a guestbook Node.js. And I believe the plan for that was Node.js. And again, this is going to interact with the service controller. That's going to ask the service broker to create an instance of this, which in turn is going to use Helm to do a Helm install. And every interaction between the service controller and the broker, everything the service controller tries to do is always done through a service broker. So the service controller really doesn't do anything but interact with service brokers. And we can now see that there is another service instance called app. And if we want to look at the cluster itself, we see that there's now a second service. This one has an external IP pending. But this Node.js service is broken. It's not going to work because it doesn't have the information to connect to MySQL. So we now need to create a binding between these two things. And what happens when we create a binding between these two things is it's going to do what it normally does with a service broker. The service controller will talk to the MySQL broker and say, hey, I need a binding to this. It will get back credentials, which is the username, password, IP port, and then it will talk to the Node.js service broker to inject that binding information as configuration. And what happens when that is done is that the broker will trigger a Helm upgrade with the new configuration, and it's up to the Helm chart to inject that information how it sees fit, whether it's through a secret or a config map or just environment variables. That, in some senses, is encapsulated and abstracted away from us as inputs to the Helm chart. Okay, so we now need to create a binding, and we're going to call this the app MySQL binding, and we're going to bind from the app instance to the MySQL instance. And this is where things start to diverge from the Cloud Foundry model, because Cloud Foundry has this concept of Cloud Foundry apps binding to services. And since there doesn't exist Cloud Foundry apps in the rest of the world, what we're allowing people to do is bind from services to services, because that's how you create a hierarchical application model. You're doing service-oriented. And I've just been given the feedback that I need to. Are you? Let me just see. Oh, it looks like the vision is cut off. Are you able to see it? You're good. Okay. No, it's just one person who's having problems. Never mind.
Brendan, could you elaborate a little bit on what you mean by binding services to services?
Sure. So when you're building a service, an application out of services, you have services talking to other services, right? The Cloud Foundry model is really kind of a hub and spoke model where you deploy a bunch of services and then you have a single application that talks to those services. When typically what we've seen is that people are building services that talk to other services. So in this case, MySQL is a service and Node.js is a service, and they need to talk to each other. So in our model, everything is a service, and it allows you to create intricate graphs of services, and even start to take services and draw a box, or take multiple services and draw a box around that, and create a new layer of abstraction that itself is a service. Does that answer your question, or do you have something specific that?
I think it gives me enough for now. I'm interested in more specifics, but I won't hold up.
Sure. So what we've done here is we've just deployed two services, and they need to talk to each other. And eventually, so we've deployed two services. We have two service instances, and those two service instances need to talk to each other, which is not really a concept that exists in the Cloud Foundry model typically. You would deploy this Node.js as a Cloud Foundry app. But since Cloud Foundry apps don't exist outside Cloud Foundry, we've migrated everything to just say everything is a service. In order to deploy your code, you would create a service type for it and then deploy it as you would any other service. And now you need to start to create bindings between multiple service instances.
Right. So Paul, the Cloud Foundry model is asymmetric, and this model is symmetric. It differs from the Red Hat proposal in that it's not just exporting credentials and config to a namespace, but to a specific, I'll use the word application instead of service just to avoid confusion with other Kubernetes terminology.
Sure, yeah.
I get that. I was sort of asking for the benefit of the group. And after this, I'll probably ask you more about how those relationships are stored, but I didn't mean to hang up the demo.
Yeah. No problem. That's it's an interesting area to dive into. And it's something that we've spent a lot of time trying to understand. Once you get rid of the asymmetry of the Cloud Foundry model, what are you left with when you're binding things together and you're creating relationships? So we've just bound these two things together. And what's happened there is that the service controller has initiated a bind request to the broker for MySQL. It's gotten back the credential information, and then it's injected it into the Node.js service instance, again, interacting with the broker API. So the service controller never has any Kubernetes native interaction. It's always interacting with the service broker API, which creates a very simple relationship of the controller to the broker for the Kubernetes environment, and potentially brokers for other environments as well. And we can see that we now have two service instances here, and we also have a binding that's binding these two service instances together. And now I realize that let me reshare my screen just so I can show the fruits of our labor, which is, for this simplistic demo. Okay, if everybody can see my, we're gonna just dig in and get the IP of our Node.js service, and we can see now that, oops, if the demo gods have been appeased. This is a very simple guestbook app. We can add messages, and then we can, we can go back and see the messages replayed. And that's my demo. So I'd like to open up for more questions. I think it was Paul that was talking before who wanted to chat more about the service instance relationship through bindings.
Yeah, I was curious to know how you're storing those relationships. Are they annotations on the service?
Yeah, so the service controller is the thing that manages all of the CRUD resources and the relationship. So each service instance has a set of bindings that it uses. When it binds, if it's a consumer of a binding, it's the from service instance. It knows about the binding information available to it, and it's the responsibility of the service controller to store that information, as well as pass that information along as configuration to the service broker when it's creating and updating that service instance within the broker.
So do you guys create secrets from the output of the broker API?
We're not in the business of dictating that. The service broker is implemented in terms of Helm charts, and the the creator of a service type is going to create a chart, and they can, obviously a chart has inputs, and they're able to do whatever they will with those inputs. So they may take those inputs from the broker and store them as config maps or as secrets for their application to consume, or they may inject them directly into their application through environment variables. We rely on the Helm chart as an abstraction layer to the service definition.
Okay, so then do you need a chart per service offering?
Yes. Yep. Yes. Every service type that you create is backed by a chart. So the workflow is I have a container. Although that is one way to do it. You have the possibility of concrete charts. That's which is the demo I just gave. I have the guestbook Node.js chart, and I have the guestbook MySQL chart. You also have the potential for more generalized charts that are my load balanced front end chart that one of the inputs is my container and does a certain pattern of, it will store bindings in secrets with this style of naming, and your application needs to be built to know how to consume it that way.
So the charts are, if I understand correctly, more along archetypes of how you want to consume information from the service. So you'd maybe have a chart that's like, this chart makes a secret with the output of the broker. This chart makes a config map. This chart does something else.
That's entirely possible. But again, you may also, like as a service creator, you may also create a very concrete chart that is, my application, and it does something very specific. But definitely, you can have multiple different archetypes that you then just are injecting your application code into.
Gotcha.
So, what about for a more black box case like SendGrid or something like that? And how would credentials be passed back to the consumer in that kind of a case?
So it really becomes quite simple because everything has to subscribe to the service broker model. So SendGrid provides a service broker, which implements the instantiate and bind interfaces of the service broker, and bind is responsible for returning a credential. So the service controller expects that when it calls bind on the SendGrid service broker, it will receive credentials back, and then it will inject those credentials in the same way it did with the MySQL credentials into the consuming service instance.
And that final motion is writing out a secret in the namespace of the requester.
The final motion to the service controller is to pass the information to the consuming service instance's service broker, and it's the responsibility of the consuming services templating to do with it what it will.
So there are bind calls for both ends of the binding.
No, there's the bind call is purely a call to the producer service, so to speak. So the service controller would, step one, call bind on the service on the SendGrid service broker in this example.
Okay.
It would receive back as a response the credentials, and then it would make an update call to the broker of the consuming service instance.
Oh, I see.
This is the new configuration for this service instance, which now includes the binding information for SendGrid. So how
does it know how to pass that information to the update call of the consumer? Is that potentially different for every combination of producer and consumer?
No. So right now it passes it in the parameters block of.
So there's just an entry like credentials, and here's the big blob of credentials.
Yeah. So the service broker API for put on a service instance has a parameters section, which is just a hash map of data. And so what we've done in this is we've said, okay, we're going to carve out a space of that with the bindings key, and the bindings key will have, a map of binding name to credential information in that.
Okay.
Yeah.
Okay.
In this world now of service instances binding to service instances, it may be that there's some addition that could be made to the service broker API to have a top level bindings section in the put call to service instances. But for our purposes, we just said one parameter to service instances now is the bindings that it needs to consume, and the service controller will inject the information there. Yep. So it's up to the Helm chart. Will receive those bindings as inputs to it, and it's the responsibility of the templating to do with that as it will.
So the model objects that you have to track these different pieces of information, those aren't being pushed back to the Kubernetes API. Is that accurate? Like they live within what you guys call the service controller. Are they persisted at all?
Yeah. So right now, what we've built is a separate service that air quote persists this information in memory right now. But we're also working on a third-party resources interface to the service controller, which would expose these things as Kubernetes resources, and these things being service types, service instances, and bindings.
Okay, cool.
Yep.
I have another question. Can the same service be consumed by more than one consumer?
Absolutely. Yep.
Okay.
Yep. And I would demonstrate that right now, but we haven't demonstrated it in a while, and so it'd probably go wrong. But this MySQL service could be consumed by two different Node.js front ends very, very easily. And the steps for that would be, I would create my second one, and then I would just create a binding that binds that app2 to MySQL. And it would issue another binding call to the service broker to get new credentials and endpoints for that new application. And then the service controller would inject that information into app2 rather than app1. And you would now have 3 service instances and 2 bindings.
Thanks.
Yep.
Hey, Brendan, Gabe here. I'm curious, is there a reason you chose to have the service controller maintain its own API and state? It sounds like you're entertaining synchronizing that with Kubernetes, but I'm just curious if there were any other reasons driving that architectural decision.
Prototype foo. We started, like I said in the beginning, we really started with the Cloud Foundry model and trying to understand what pieces of that can be abstracted or extracted and generalized to create a service management system. And when doing that, we weren't solely focused on just saying, how do we manage services in a single Kubernetes environment, but really like, how do we manage services in general, possibly across multiple environments? And so we were just operating with the simplest use case, and that was, build a Go binary that we can interact with through a RESTful API. And now we're trying to say, okay, well, how do we integrate this seamlessly from a user experience perspective into the Kubernetes system, and understanding how that would look and feel, and whether that model still fits once we do that is what we started focusing on next.
Right. Yeah, it makes perfect sense, and I think. Trying to build something that isn't or explore something that isn't tightly coupled to the Kubernetes API certainly makes sense. But if I'm understanding correctly, it seems that the service instance creation, sort of the plan registration, is using Helm right now. That is kind of the de facto way to get that in there. Is that accurate?
Yeah. So Helm is the mode of creating service types. I define my service as a Helm chart, and that allows for the declarative parameterizable service definitions, and it also gives the beauty of that abstraction of what the service is and what its inputs are.
Great. And, just for my, just to get this out and for other folks on the call, it seems, as far as I can tell, there's sort of 2 or 3 major differences between Service Controller and what we were showing before with Steward. The first is that it seems like Service Controller, has, at least for now, this own API and state versus using Kubernetes to store the contents of the catalog. And then also Service Controller uses the Helm Chart rendering to allow for more flexible use of the binding data versus secrets injection, which is what Steward's using. That, and then maybe the third thing being the Helm supporting a few other modes that we're kind of playing around with. As far as I can tell, those seem to be the major differences in approach.
Yeah, and let me just maybe add to that. I think one of the big things is that there's an echo. Oh, is that you? Oh, okay, thanks. There's a bunch of us in the room, and we're all wearing headphones. So, so I would just add to that to say that we really focused on keeping the service controller and the service broker as separate principled layers, such that the service controller doesn't understand Kubernetes and it doesn't understand Helm. All of that is encapsulated in the broker. And the more we can do that, the better, because whether we need a layer of abstraction for services, whether it's the Cloud Foundry service broker or something else. But when you have that very clear API for managing service instances and managing bindings, you get a bunch of very nice properties, I think. One of which being able to manage across multiple environments. And so I think just to add to your point, I think the service controller really doesn't use Helm. The service controller just uses service brokers, but we also built a service broker that uses Helm that has all of those things that you just described.
The one thing we did also bolt on top of Helm is schema support, and to go ahead and get output parameters, we use the nodes.txt in a very machine parsable format. So we get the input-output behavior from schemas and nodes.
Yeah, one of the really important aspects of having this service broker layer is that we need really strong input-output properties from Helm. And I think what Ville just said is notes.txt is great, but we really needed to have a machine parsable notes.txt, the ability to program against a notes.txt. And for that, we just have notes.txt output YAML or JSON, but it's really good to be able to, some of the issues we ran into were programming against Helm, where some of the things were really designed more as a usability aspect in an interactive model. And I think once you're building a system on top of Helm, there's maybe some rough edges.
So Aaron here from Deus. So did I hear right that it may be possible to write a broker that didn't use Helm to instantiate the app?
Yeah, that's the beauty of the broker. You could run a bunch of different brokers in your Kubernetes cluster, and one of them could be using Helm. We've been playing with a broker that uses the Google Cloud Platform's deployment manager. You could write a broker that just uses kubectl and deploys things. I think you lose a lot of properties like the abstraction layer that Helm charts give you when you start to do that. You have to start defining what a service is in broker code rather than in like the values, the input properties and things like that. It becomes more challenging to schematize things. But yeah, you could write a bunch of different brokers, and they all manage things in your cluster in different ways using different tooling. Absolutely, that's the magic of the service broker.
Yeah, so that definitely has some advantages. My own personal taste lies with having something that knows how to manage the Kubernetes end of it, because if you have that, you lift up the responsibility for interacting with Kubernetes out of the broker, and you make it easier and easier to implement a broker because the surface area of the things that the broker has to do is smaller. So I don't want to diminish either demo. They're great demos. Just putting my own opinion out there, as I've been known to do from time to time. So
could you clarify that? Oh, if we're out of time, we're out of time. We can talk.
No, I'll clarify it. So what I mean is that if you push onto the broker implementation the responsibility of managing Kubernetes resources, that's fine. But a consequence of that is that you have to understand how to interact with Kubernetes to build a service broker that's going to work with it. So I think it has utility to be able to delegate the management of Kubernetes resources to the thing that's on the other end of the broker API. In this case, it would be the service controller. And there's nothing to stop you in that model from implementing a broker that's smart. If you want to implement a broker that will do white box services, like create actual deployment resources and pet sets even in your Kubernetes namespace. But I think there is some utility to having a controller that is whatever you want to call the thing that's calling the service broker API that knows how to manage Kubernetes resources. At least the least common denominator ones, which are like, in my mind, a service and a secret. So that's not really a criticism of your demo, Brendan. That's a general thought about this area.
Yeah, that's interesting. I think I would have to digest that a little bit. And,
well, maybe I can respond to that. I think I understand what you're saying. It's a little confusing because we talk about the service broker both on the consumer side and the producer side. And so Cloud Foundry really only has the producer side service broker. And what we're doing is we're saying that everything, even consumers, are modeled as service brokers. And so the update, sort of the responsibility for propagating in the environment that you're in is with the code that is running in your environment. So if you're in Kubernetes and you're consuming a service, then the service broker on that side knows how to propagate bindings and things like that in a Kubernetes native way, right? And that's what we've done with the service broker we implemented that uses Helm. But if you sort of expand, we don't consider Kubernetes to be an island, right? You might actually have a service graph that spans Kubernetes and other places. Then you can't have the service controller know how to shove bindings into Kubernetes and into AWS and into in anywhere else. So you have to delegate the responsibility for the last mile of binding propagation, and that's why we sort of saying there is an API, the service broker API, where we can update those parameters, and wherever that calling code is coming from is responsible for that. I don't know if that helps.
Yeah, so I think Gabe's comment in the chat that there's just a key difference in approach in terms of like how I'm thinking about this and how you guys have chosen to think about it in the service broker prototype. I think your scope was more ambitious than anything that I have imagined. I never have considered the use case of managing multiple Kubernetes or multiple paths on the consumer side at all from a single instance of such a thing.
Yeah, I think one way that I'm thinking about this is using the service broker API itself as a backward adapter into an application environment. So that put on that service instance with the set of credentials, then the implementation of how that actually gets onto disk is something that's provided by the packaged application. If that makes sense.
Yeah. So we are over time now, and I do want to quickly cover this last agenda item. Thank you, everybody, for your demos. The last agenda item is if there is interest in a face-to-face meetup at KubeCon or slightly before or after, I'm interested in reading the temperature of the group for that. I think that face-to-face meetups are really awesome for, one thing, getting to see other people's faces and, establishing relationships that can help things like move a lot smoother and give you some contextual information that you would never get on a SIG meeting like this. So I personally will be at KubeCon. I'll be there. I'll be in Seattle that week starting Monday, and I'll probably try to fly out on Friday. I think Jason, perhaps you can be the trendsetter. If you're interested in such a meetup, could you just put a +1 into the chat? And we'll allow 2 or 3 minutes for +1s to trickle in.
So Butcher from Days and I have been chatting about that, doing a Helm developers conference here, and I have booked the room for Monday for that all day. So more information if we can slip it on top of this, because it seems like there's a lot of work from Days being put into this as well. So.
Yeah, I think if you guys already have a all-day location set aside and you'd be willing to donate an hour or 2 of that for a face-to-face for SIG Service Catalog, that would be awesome and appreciated.
I have 0 problems with that. It is a Monday, and I can. I'll talk. I'll send the details offline if that's okay, and then we can distribute them to SIG however we see fit.
All right, great. Well, I only see a couple +1s in the chat. I'll start a thread on the mailing list this week, and we can work this out. We've got a little bit of time in which to do it. So thanks, everybody, for your demos. I think this is awesome food for thought. I do want to encourage folks, like if you have interest in bandwidth, if you would like to contribute use cases to the incubator repo for the Kubernetes Service Catalog, I would welcome your pull request, and I am going to be setting aside some time this week to get a more complete use case analysis in there. I have a number of different things I'm kind of juggling, but I want to make a big push on that this week. I think that's all I've got, unless anybody wants to say anything. You all are ready, or I think that's all we've got. Anything else? Going once? Going twice? All right, sold to all of you. Send the check to my house. See you all on the internet.